Hello and welcome to the Analog Devices Precision Digital Isolation Technology Training videos. This video is the third in the series and will focus on important digital isolation terminology. We will review the important physical characteristics and high voltage specifications. Insulation is categorized and graded based on the level of protection offered. The lowest level is functional isolation, which doesn't offer any guarantee of safety. Safety insulation has several grades, offering increasing levels of protection from basic up to reinforced. Basic insulation protects users from electrical shock. Supplemental insulation is an independent insulation layer applied in a system to protect from faults that might breach a basic layer. Double insulation is both basic and supplemental insulation applied together. Reinforced insulation is a single insulation system that's demonstrated to be the equivalent to double insulation in terms of the protection provided. Components providing reinforced insulation may need to meet additional structural requirements, such as minimum thickness of solid insulation or multiple layers of film insulation. There are several important voltages in high-voltage systems that impact isolator design, construction, and testing. Beyond the magnitude of the voltage, a key concern is the duration. How long does the voltage exist across the insulation barrier? Transient voltages exist for very short periods of time. They can be very brief, in the nanosecond range, or up to milliseconds in duration. The withstand voltage rating defines the ability of the insulation to survive at least 1 minute with a 60 Hz high-voltage sinusoid. At the extreme end of the timescale is the working voltage, in which the insulation must survive continuously for decades. A unique characteristic of digital isolators is that the packaging is very important, and in fact is an integral part of the device, much more than most semiconductors. The two main package-related characteristics are creepage and clearance. Creepage is the shortest distance across the surface of the package between conductive parts. This dimension is important because surfaces build up small conductive filaments when subjected to high voltages over time. These filaments eventually join together and will produce a leakage path in a process known as tracking. Increasing the creepage distance allows the package to withstand higher voltages for longer periods of time. The amount and type of contamination present on the surface will also impact how rapidly tracking occurs. Clearance is similar, but is measured through the air. The clearance of a package will determine the maximum transient voltage that may be applied without arcing across the barrier. Air pressure and gas composition have a major impact on this process. Analog Devices has many digital isolators that provide trusted safety and data integrity. To learn more, please watch the next in our Precision Digital Isolation video training series. Click on the link below or visit analog.com/iCoupler.